In this video, we are going to talk about air-cooled condenser chiller. This machine is used to generate frozen water in applications where low and medium thermal load is handled. Welcome to episode number 4 of our series, Chiller, the Water Chiller. As we saw in previous episodes, the chiller consists of a basic refrigeration circuit, where we need to remove the heat that was taken from the water in the condenser. By the way, the link to our first episode is popping up right now, if you want to start this study from scratch. The water-cooled chiller has a higher performance than the air-cooled one, because logically with water cooling it is easier to remove the heat and lower temperatures are achieved in the condenser. However, not every time you have the space and water resources that a water-cooled chiller needs. Air-cooled chillers usually work with scroll and screw-type compressors, although it is not a general rule. Scroll compressor air-cooled chillers are used for lower capacities. However, there are chillers with several scroll compressors. In this way it is possible to reach medium capacities. In addition, the fact of having several compressors allows the chiller to regulate its capacity, although we will see this in a later episode. The parts of a chiller, cooled by air are 1. Cool, where the evaporator of the chiller refrigeration circuit is located, and the passage of heat from the water to the refrigerant is carried out. At this point, due to heat gain, the chiller refrigerant changes from a liquid to a gaseous state, while the water only lowers its temperature and becomes ice water. 2. Compressor, where the refrigerant arrives in a gaseous state, with the aim of raising its pressure and thus facilitating the return to the liquid state. 3. Air-cooled condenser. At this point, the gaseous refrigerant, due to its high pressure, recovers its liquid state, since it is quickly cooled by the air, which is introduced by powerful fans. 4. Liquid receiver. In this part the condensed refrigerant arrives. In this way the condenser is freed from the liquid refrigerant that it is generating. 5. Expansion valve. As the liquid refrigerant still has high pressure, it is necessary to pass it through the expansion valve, which is responsible for recovering the low pressure and returning the low temperature to the refrigerant. The thermodynamic properties and states present in an air-cooled chiller are 1. Water inlet at 54 Fen 12 Ec. 2. Chilled water outlet at 44 7 Ch. 3. Inlet of liquid refrigerant at 7 C and low pressure. 4. Outlet of refrigerant in vapor state at 10 C and low pressure. 5. Outlet of refrigerant in superheated vapor state and high pressure at 7 Ec. 6. The refrigerant changes from a gaseous state to a liquid at 50 Ec. This point is under high pressure. 7. The fans introduce outside air at a temperature of 35 degrees Celsius in order to cool the condenser. 8. Refrigerant in liquid state at 40 degrees Celsius and high pressure. 9. Low pressure refrigerant output at 7 degrees Celsius. Right now a link to a related video is appearing that will surely interest you. We suggest you watch it, and of course subscribe to our channel. Thanks for joining us.